Today I will synthesize iron-chelated polylipoic acid, a self-healing material. Lipoic acid is a substance commonly used as a dietary supplement. When I tried to purchase it from chemical suppliers, 25 grams of it cost approximately $300. However, I managed to buy 50 grams of pure lipoic acid for $40 from a local pharmacy in my neighborhood. First, I heat the lipoic acid to 120 degrees Celsius to induce polymerization. During heating, the bonds between the sulfur atoms in lipoic acid break homolytically, forming sulfur radicals. One of these radicals forms a sigma bond with a sulfur radical from another lipoic acid molecule. This process connects multiple lipoic acid molecules, resulting in the formation of polylipoic acid. Adding a crosslinker would produce a more dryable polymer. But since my goal in this study is different, I'm not using a crosslinker. I add iron trichloride solution to the molten polymer. After heating the mixture for a few minutes, I pour it into a mold. If I didn't add iron cation to the lipoic acid melt, I would obtain a brittle polymer. Iron chelates with some carboxylates from different lipoic acid fragments, strengthening the attraction between the chains. This results in polymers with stronger intermolecular bonds. Cations of other metals can also be used instead of iron. In one of my previous studies, I demonstrated that a metalloid, boron, could also produce elastic polylipoic acid. In about 10 minutes, I remove the polymer from the mold. Now it's time to test the polymer's self-healing property. Two separate pieces of the material fuse together quickly, much like how a cut on our skin heals itself. However, under tensile stress, the polymer broke at the relatively weaker damaged area. This self-healing mechanism works through the reformation of bonds between sulfur atoms on the cut surfaces. These dynamic bonds provide the polymer with its self-healing capability. I have several different designs in my mind for self-healing polylipoic acid. Once these studies are completed, I will share the results here.